guys already can see my screen?
Yeah, sure.
Yep.
I'll speak lah. Then I'll tell you next slide when I need it lah.
Okay.
So you will control,
Yes.
and then yeah, then I'll hand over to you when I'm done with my part. Yeah.
All right. Is this your first webinar?
No, I've done quite a few since.
Oh, okay.
Yeah, I think we start doing webinar 2021 last year lah. Yeah.
Okay. Yeah. Since COVID.
I don't know, Marcus. Wait, what? Done 5 or 6 already so far?
Oh, okay.
Easy, wrong.
So guys, there are 5 attendees. I think everyone can hear you.
Yes.
Oh, okay.
Okay, we will start probably at 3:03 lah. Yeah, just wait for a few minutes.
Charles, can you see the people coming in?
Yeah.
Yeah. So, oh yeah, okay. So yeah, maybe we will just wait for.
So can you view that?
As panelists, I can't view the party. Oh no, actually I saw attendees. Yes, I saw it already.
Yes.
Yeah.
You have to click the attendees.
So Marcus, there's the next tab on nearby panelist. You can see that.
It's next to the Q&A at the bottom.
Yeah. So we just wait for maybe
3:03, 3:02 lah.
Yeah,
A few more minutes. Yeah.
I think some of the customer already.
Yeah. Hi everyone. So just give us a couple of minutes. We'll be starting the webinar exactly at 3:03. Yeah, so waiting for more people to give people some time to come in. Hi everyone. So I think we can slowly start, and I just cap off with a little introduction of what we do at I-VTech. So hello and good afternoon. I'm Yi Chao from I-VTech Solutions, sales engineer. So together with Tech Data and Autodesk, we jointly present today's webinar for skid and plant design. Yeah, so can you go to the next slide? Yeah. Okay, so before we begin, let's do a brief introduction of us. So we are I-VTech Solutions, authorized Autodesk reseller partner. So we specialize in product design and manufacturing. So our company has over 20 years experience in providing computer-aided technologies and related software solutions. It comes to drafting, 3D design, modeling, analysis, simulation, and together with other related end-to-end solution and services. Next slide, please. So what do we offer exactly? So as I say, we provide end-to-end solutions based on our customer needs and goals. Let's break our services down to these three pillars: design, use, and make. And some of the solutions we provide. So under the design umbrella, we have 3D modeling and drafting. And for simulation and analysis, we specialize in simulation for plastic injection molding, CFD, computational flow dynamics, and FEA services. So these are software that perform simulations that reduce the need for actual testing, and we predict a product failure in real world scenarios. So we can reduce costs and waste during design and manufacturing. And then under the make, we provide CNC post-processing, and the very popular these days, we offer 3D printing services. So lastly, under application, we cover both software and hardware implementation, and especially so customized training of software and systems. So especially if you very relevant today, like how do you apply Inventor and say maybe AutoCAD to some of the applications and goals that we will showcase today. So we also provide such training, and we can even customize to your current needs and requirements, and based on your backgrounds and so on and so forth. So yeah, feel free to contact us. So I mean, I will show you our business contact information at the end. Next slide, please. So just to show our current clienteles over the years. So we have expanded, and they are from a wide variety of industry and segments. So we have government agencies, Institute of Higher Learning, research institutes, oil and gas, semiconductor, electronics, plastic injection, and consumer products. So this shows that we have been really offering value driving end-to-end solutions where our customers have been valuing us. And lastly, next slide, please. I'll paste in the chat box our contact info. So yeah, you could just copy it accordingly. So this is both our sales engineers, myself and Marcus, email contact, and this is our company's email to show more range of courses and solutions that we provide. So I'll hand over to our main guest speaker today, Mr. Samsul. So he will be delivering the core of the content. Next to you.
Okay, thank you.
Thanks.
Thank you, Marcus. Hi, good afternoon, everyone. So let me share my slide first. Okay. All right. Good afternoon. My name is Shamsul, the solution consultant for I-VTech Solution Malaysia. We actually partner with the I-VTech in Singapore as well. So today I'm going to talk about the seamless skid design with a Autodesk plant solution. Okay, so a little bit introduction on Autodesk. I believe that everyone heard Autodesk. Maybe not heard Autodesk. Maybe everyone know AutoCAD, but doesn't know what is Autodesk. So Autodesk is actually a company, the parent company of AutoCAD and other softwares. Okay, we have started more than 38 years ago, and then we are listed in Nasdaq. The revenue is quite big, about 3.2 billion in 2019. We have more than 9,000 employees, and then most importantly, we have 200+ million consumer users. Okay, and also 12 million professional users. Okay, and also the students in the university and even in the school are having access to Autodesk products such as AutoCAD, Inventor, and also Revit. Okay, so Autodesk started in 1982 with a platform solution and imaging business. Okay, by along the time until now, 2022, Autodesk has emerged widely to cater the industry, most of the industries, such as the AEC industries, the design and manufacturing, media, entertainment, as well as oil and gas industries. So, as of now, Autodesk already have more than 100 products, okay, more than 100 solutions or softwares, okay, and 200 million users around the world. Okay. So these are the main industries that we cover. Autodesk covers, which is the AEC, architecture, engineering and construction, the manufacturing, the design and manufacturing, okay, and then the media and entertainment, and also oil and gas. Okay, so so today we see the fundamental disruptions in three areas, the three main areas going to combine to create a seismic shift in the industry. There are the changes in the means of production, and how the teams plan, how the team design, create and operate infrastructure assets. And then changes in the nature of demand for resources, changes in the products as devices, equipment and systems deeply intertwine the physical and digital worlds. So let's take a closer look. So what are the industry challenges in the oil and gas or plant industries? So every business owners want to win more business. Okay, we want to be the reliable, the efficient, and deliver the performance to the clients and customers. Okay, so we want to increase the complexity of the projects. The demand is actually increasing on the complexity itself, and also we have tight schedules, tight deadlines, and tight costs. And coming to the new year 2022, every materials prices are going up. So we have to find out how do we can cut the costs and meet the tight schedules and deadlines. Okay. So of course, to cut costs, we need to the low cost plan design solution for plan design. So the low cost mostly focusing on execute the smaller projects. Okay, the smaller projects can be done faster, cheaper. Okay, you can maximize designer experience and confidence by doing this faster and accurately, and then produce deliverables in client preferred format. So it's not only that we produce AutoCAD, in AutoCAD, we deliver the formats in DWG and .DWG. We can also produce in the client's preferred format as well. Okay, so to collaborate between designers more easily. Okay, so what are the industry requirements in the process plants? In piping design, beside isogen, would they use piping for mechanical layout? If we provide DWG of piping in plan view, etc., would they really use it practically? Sectioning for elevation. Okay, so the requirements comes from the process simulation, okay, the process flow diagram, the PFD, the PID drawings, equipment specification, and so on until the project management. Okay, so it covers everything basically in the plant process plant industry. Okay, so this is the typical engineering workflow for oil and gas or plant industry. So the first thing, of course, we get the 3D or 2D drawing data from the customer or consultant. Okay, so we start the project from getting all the documents and drawings, and then we go to the project bidding and management, and then we go to engineering. So this engineering has a lot to do with the design things. Okay, after engineering, we go to procurement and then the ERP integration. Okay, so in engineering, okay, this is what we are focusing on, what we can save costs, where we can save costs, where we can reduce risk. Okay, so typically, commonly, most of the companies are using multiple design tools for 3D modeling, for PID drawing, for analysis. Okay, multiple design tools, which means from different company, which is the collaboration between the files are hard or not seamless. Okay, so let's say they are using 4 applications, A, B, C, D, then everything will be exported to AutoCAD. Okay, eventually they will export it to produce the 2D detailing and drafting. Okay, so everyone use AutoCAD now. So from AutoCAD, then we go to the shop drawing. For the shop drawing done in the AutoCAD can go to the fabrication. So what are the problems with this typical workflow? So it is a fragmented process, okay, multiple of overlapping engineering design applications. You have a limited integration from engineering to ERP, okay, limited collaboration tools with customer and construction. So most engineering design still done in 2D AutoCAD. Okay, so yeah, I know that it's already 2022, but people are still stick with the 1990s way or maybe early 2000s way. So we are moving 20 years already. So the technology is there, but people are not using it. Most people are still stick with the traditional way. Okay, so here is the Autodesk solution. The workflow is the same from 3D to project bidding and all, but during the engineering, okay, we are providing only one platform, okay, not one application, actually one platform, which is the Autodesk platform, to do the 2D drawing, PID, the plant 3D, piping drawing, and also visualizations, and as well as the stress analysis or analysis applications. Okay, so under one platform, what is the good thing on one platform? It allows you to it allows the integration in between applications to be seamless. Okay, because it's all in Autodesk, so the integration, the interoperability between each software, each application are seamless. Okay, the overlapping application problems usage can be eliminated by using the application from same platform. Okay, so the Autodesk plan design workflow. Okay, in plan design, of course, everyone needs the PID and drafting drawing. Okay, we need that, and then we move to plan 3D. Some of them are only sticking into PID drawing only, but not plan 3D. What's the problem? Is the problem when you have only 2D drawing or 2D PID drawing, you will get all the information that you want, but you cannot visualize how the plan will work. Okay, what are the height, what are the length, everything, because in PID it's purely on the spec. Okay, and then we go to plan 3D. Okay, in plan 3D we have a 3D piping and spool drawing, which is the isometric drawing. Okay, and then equipment and skid design. So equipment and skid design can be done in Inventor, Autodesk Inventor Professional, and of course in Plan 3D itself can be done, can create the equipment drawing as well. But the best to do the skid drawing and equipment drawing is in the Inventor Professional. Okay, and then we go to structural design, structural designing, and orthographic drawing. So this one can be done in Plan 3D. And also we have other applications in Autodesk, such as the Autodesk structural detailing to do the structural design and detailing. Okay, and then for the visualize, we go to the project review, the clash detection, okay, and collaboration, drawing collaboration in Navisworks Manage. Then we do the MAP service with the AutoCAD MAP. So this is Autodesk plan design workflow. We use all these applications, okay, within one platform, which is the Autodesk platform, to do the whole plan design workflow, right? So the task coverage, like what I explained, is AutoCAD. Everyone knows AutoCAD already. Design and draft the powerful and flexible features. Okay, the PID. Okay, this one is the most important thing, and not important. It's interesting about AutoCAD Plan 3D, because previously or currently most of people doing PID using normal AutoCAD. So you do not get the specialty of AutoCAD PID. The what we call it the specialty of AutoCAD PID with AutoCAD normal AutoCAD. Okay, and then we go to 3D piping with AutoCAD Plant 3D, and then equipment skid design with Inventor Pro, and also project visualization and review with Navisworks. So I will show you what all the software or all the application can do with a quick demo later on. Okay, just stay with me. I'll show you the interesting part about these applications. So this is the integration in between the software. So you can see here that our goal is on the Plant 3D. So we wanted to create a complete plant design in Plant 3D. So with Inventor, that you can create a skid drawing and skid design. Okay, you can export it into Plant 3D with the .adsk. ADSK is the Autodesk exchange file. So Autodesk has its own exchange file in between application. So it will open the drawing accurately in other application. Okay, and then in AutoCAD Plant 3D, we can export it into DWG. Okay, we export the WG, then open it in Navisworks, where you do the aggregation of multiple models. Okay, which is the structural equipments and pipings. Then you can do a walkthrough, do markups and project collaboration, clash check, and also for the simulation. Okay, so I'm not going to talk about advanced steel and Revit as of now, because it is out of scope of the plant design. But of course, a little bit introduction. Revit is for AEC industry, which is architecture, engineering, and construction. So, but also if it's suitable for you, then you can use it for the drawing, the building design of your plant. Okay, and advanced steel is for the steel detailing, structural detailing. Okay, so PNID. Okay, the first one, PNID and design and drafting. So PNID is built within AutoCAD platform. Okay, nowadays when you buy AutoCAD, you get all the tool sets together that include AutoCAD Plant 3D and PNID. So it is easy to learn, as it's very similar, very same as AutoCAD, the normal AutoCAD, but there's a few other features that not available in the normal AutoCAD. Then a quick PNID creation and editing. Okay, you can do automatic nozzle placement, automatic path alignment and insertion. Okay, it comes with industry standard symbols. Okay, what are standard symbols available in the industry? Say about ISO or DIN. So all the standard symbols are available inside PNID and Plant 3D itself. Okay, the simple data handling, the spreadsheet like a data manager available in PNID is very useful for you to do the takeoff. Okay, you can do Excel import, export as well. So unique tag checking, annotation updates, off-page connectors, and also data validation between PNID and 3D. Okay, so these all features, actually, you cannot get it from normal AutoCAD. Okay, the quick PNID, simple data handling, the standard symbols is not available. In normal AutoCAD, you will need to create yourself everything. Okay, and there is no connection in between the lines or the pipelines and the equipment. Okay, it's all lines. The normal AutoCAD is all lines, right? Okay. So the workflow. We come from the PNID creation. Okay, then we validate the rules. Okay, and then we go to the change management using the Excel export and import, and then create a report from the management. Okay, and then go to PNID to piping, which is the 3D. So from PNID, we can make it as reference to create our 3D piping. Okay, so a little bit about PNID. I will show you a technical demo a little bit. Okay, so this is the AutoCAD PNID. All right. So if you see here, it is similar to normal AutoCAD, but it has difference between the tool palettes. Okay, palettes is missing. Okay, here. Okay, tool palettes, we have standard pipelines, we have standard instrument lines, the equipment symbols. This is the standard equipment symbols that I explained earlier. And then the buff, okay, and there's a multiple buff, but of course you can create your own symbol. Okay, this is based on standard, but if there's a special or custom symbol for some suppliers, then you can add it yourself. Okay, and then fittings, okay, the symbols for fittings, instruments, and also non-engineering symbol. Okay, so in PNID, what's best about PNID? Then I open an empty drawing. Okay, right. So I'm going to create or place an equipment into my drawing. So what I need to do is just go to, sorry, cannot see, there's a, my Zoom is blocking my view. Okay, it's okay. Sorry for that. Then you can insert, equipment here. For example, equipment, you can just select from the tool palette, place the equipment, then you can see it will appear the assign tag. Okay, this is the unique tag assignation. So number, you can put your number into, let's say 2222. This number, tag number is unique. You cannot repeat the number. Okay, so set as equipment tag, assign it. Okay, and then put the annotation there. So it immediately, when you place one blocks or one equipment, it immediately has the annotation as well. Okay, so when you add another parts, for example, I wanted to add pumps, so I add one pumps. There's a standard pump, say 2022. Okay, pump, I put the annotation down there. Okay, so now you can see I wanted to connect the vessel to the pump. So I have to do, I just create the pipelines. Okay, why we use pipelines instead of normal lines in AutoCAD? Because pipeline has feature that, you know, there's already an arrow there. Okay, and then when I connect it here, oops, sorry. Okay, when I connect the pipe, okay, this is not a normal line. And see, there's a assign tag. So with the assign tag, you can directly set the size. For example, I'm going to set 150. The spec is carbon steel 150. Okay, pipeline group, you can choose from here, from the various selection here. You can choose which type of pipeline group service that you are drawing. Okay, for example, I'm going to show this general process, and then the group, line group. Okay, so same goes to the equipment. You can also make the annotation directly when you assign the tag. So assign, then I put the tag down here. Okay, so next is I'm going to add some valves into the pipe. Okay, now I can see here, this is my tag number. I have a 150 spec, size. I have CS 150, general process P, and the line number. When I add a valve, for example, a gate valve, okay, I just place it here. Okay, you see the line is continuous. So when I place it, it automatically trim the line and put in the tag. Okay, so you don't need to do double work to trim everything. Okay, even if you move it, okay, move it to the other place. Okay, the previous place already continuous, and this one already trimmed. Okay, next I'm going to add one more a check valve here. Okay, it has the size because it reads the pipe size. Okay, I can even change the behavior of the valve. It's either normally open, normally closed, or others. Okay, so set end connection, and then I can change the flow of the valve. Okay, by just clicking here. But now But then if you wanted to change the other buff, what you have to do is just click the button here because it's already preset, already done, already provided by Autodesk. Then you can choose which buff that you want to use. Want to change. Let's say I'm going to change to ball buff, and I change to ball buff. Okay, it's easy, it's direct. All right, so oops. So you can see here, for example, I do a little bit more example here. I add more buff. Okay, when I connect, I wanted to connect this vessel to this tank. So I just click here and then I click to the tank. So what happened here, when it connects to the tank, it automatically add nozzle, because if you think logically, every pipeline that connects to the tank should have a nozzle, should connect to the nozzle. So when you connect to the tank, it will add the nozzle. Okay, and also the overlapping lines or overlapping pipe will be trimmed as well. Okay, so that's PNID. Okay, so everything that you already draw inside your PNID drawing, PNID design, you can get all the information, okay, or the table, the BOM list, actually the part list inside of the data manager. So you can see here, you can filter it by engineering items. Either you want only equipment, you want only pumps, you want only tanks and all, or you want the whole engineering items report or a BOM list. Okay, so these engineering items, this data manager can be exported into Excel file. Okay, so you can export it into Excel file, select where do you want to save, and then you can save it. So when you save it into Excel file, any changes that you've done in the Excel file, you can re-import it into it and it will synchronize the file. Okay, for example, you add supplier name, you add comment name here. Let's say the designer doesn't know the supplier name or the manufacturer name. So what they do, they export it to Excel and send it to the procurement. Then the procurement will fill up everything here and then send back to the designer. Then you can update it in your drawings. Okay, so when open here, there's a lot of paths, of course. I don't know which one is which. Okay, for example, the gate valve 2001. You don't know where is it located in the drawing. So what you have to do is just click the gate valve and click visualize. Okay, then it will show where is the location. It will highlight the location of the valve, each valve. Same goes to the say the plug. So what else I can show? Assume nozzles. Okay, this one. So I just click the item. Oh, this one is assumed, it's not available here. Let's say this one. Okay, so E100 is here. So it's easy for you to navigate throughout your drawing. Okay, so this is about PNID. You can see on left here we have the standard drawing where, sorry, not standard drawing, the project files. So every drawings that created in this project will be stored in one folder. That makes your project data management easier. Okay, it will not be stored in different places because the project cannot read it. It will show that there's an error that cannot read the project out of the project file or project folder. All right. So from PNID, okay, the line list, this is not only the tag. Okay, this tag will be useful during the piping, the 3D piping creation later. Okay, so you will use this one. You have already determined everything that in the pipeline. Then you can use this pipeline in your 3D piping creation. Okay, so okay, that's about the PNID. Okay, you can explore on later because that's all. Not that's all. That's what I'm going to show you right now. Okay, so I'm going to move to the skid drawing. That's 3D drawing. Sorry. Oops. Okay, so this is the PNID. Okay. Okay. Next is the PID to piping design workflow. So this is the PID line list that I just said earlier, that the tag, the pipeline tag is not just a tag. Okay, it will be useful. So in Plant 3D, you will have the PID line list. This is for you to get the reference on to do the 3D piping, so that you will not miss anything, or you will not get the wrong line number during the 3D creation. Okay, and then we go to the 3D drawing, which is the spec-driven piping. Okay, because all the piping created in Plant 3D is spec-driven, and then we go to GA general drawing. Then we go to clash checks. Okay. So from the orthographic drawing, the GA drawings, then we go to clash check using a Navisworks or visualization, that we can create the isometrics for construction. Okay, this is the most important thing that can create needed for the construction, because this is the final drawings for construction. So we do PID, Plant 3D, orthographic, and then even finally we need the isometric drawings. Okay. So the structural modeling. AutoCAD Plant 3D also has the structure creation feature, because you can create structural modeling faster with all the structure standard catalog available in Plant 3D. So there's a lot type of skills available for stage creation, the platforms, and as well as the ladders. Okay, this structure drawing created in Plant 3D can be exported to other applications for the steel detailing or steel analysis. Okay, via the SDNF, which is the steel detailing neutral file. Okay, so next is the equipment design. Okay, so a powerful tool that Autodesk provides for part and assembly drawing is the Autodesk Inventor. So what are the benefits that the plant designers and equipment suppliers can get with Inventor? Okay, for plant designers, you can work better with the equipment drawings from the supplier. You can use their design data from suppliers directly and efficiently if the design data is using Inventor as well. The most important is to reduce the plant design error possibilities and also react faster to any design changes. Okay, I will show you a short video how this equipment design changes can be done in few seconds. Okay, so for the supplier, you can take the full advantage. You can design the equipment in you can take full advantage of highly efficient mechanical CAD system. You can design the equipment in Plant 3D itself, but of course, normally the piping designer don't do the equipment design, right? So normally we get the 3D drawing from the supplier for the equipment design. So here's the thing, the file format you got from the supplier needs to be brought into the drawing. So you can convert it into Autodesk Inventor and then import it from Autodesk Plant 3D. Okay. Okay. So equipment design workflow. So from 2D drawing that we got from the supplier. Okay. So you need to design back. Some of the supplier doesn't give you the 3D drawing, so you have to redesign it. Okay, make it to 3D. So you can reuse the 2D AutoCAD drawing that you got to create your own parametric design and automation. So you use Autodesk Inventor to create the parts design, and then go to construction drawing, and then of course we go to the FEA simulation to see whether the strength of the parts that you just designed or created. And then we go to the skid design. Okay, we create a platform, okay, put all the materials, put all the equipments and connections. Okay, and then we integrate it with the piping design. Okay, this is the equipment design workflow. So this is why I said earlier that designer can react faster. This is the feature in Inventor that you can change the size of the equipment. For example, this vessel needed to be bigger. So with few clicks, you can already change the vessel capacity, and then as well as the piping routing. You can see when it changed the vessel size, the piping routing is also changed accordingly, and also the structure. Okay, it changed accordingly. Of course, that means you don't need to do every modification, every part modification. What you need to do is just change the size of the vessel. Okay, one click, one change, everything is changed as well. Okay, so you don't have to do 2 or triple works, okay, double or triple works. Okay, but of course, this comes with a few settings that you need to configure beforehand, but it's very simple to configure. Okay, no worries. So skid design. So the frame design, the frame analysis, automated material takeoff can be done in Autodesk Inventor. So you can create the skid design accurately, the material library that available. Hold on, playing the video. The material library in Inventor, available in Inventor, allows you to choose from various type of standards, okay, or family. Okay, you can easily design the frame by just choosing what type of frame you need, and connects each frame with each other with the connection setting. Okay, so the structure created in Inventor, of course, need to be analyzed. Okay, because you don't know the strength of your structure, of your design structure. So once the design of the structure is completed, then you can run it. This is the connection setting. Okay, you can set the connection, then you can run the simulation, the static or nodal analysis. Okay, choose which beam properties, any beam properties. I can apply the stress, apply the load. Okay, and then you can run the simulation. So once the design is confirmed, okay, when you already run the simulation, you got the approval that the design is strong enough, then you can proceed with the shop drawing. Okay, so the shop drawing is the orthographic drawing, of course. So I'm skipping a bit. Okay, so this is the orthographic drawing, the shop drawing. Okay, to send to the fabricators to fabricate the structure, right? So next is 3D piping in AutoCAD Plant 3D. Okay, we do the skid design in Inventor, and then we do the 3D piping in Plant 3D. So, okay, so why we do in the skid design Inventor or equipment design in Inventor? Because Inventor is a special tool specifically for part design, for skid design. So that's why we don't do it in AutoCAD Plant 3D. Okay, because in Plant 3D you can do structure yourself, but there's no simulation test. If you need simulation test or stress analysis, you have to export it into other software, other applications such as the Autodesk Nastran, or go back to Inventor to do the stress analysis. Okay, so in 3D piping, the piping creation in Plant 3D is spec driven. Okay, it's all depends on the spec that you choose. Okay, you will always attach to the spec when creating the piping, so that you will not miss or mistaken the piping in between spec. The piping modeling is pretty easy. To edit or modify the drawing is also easy. The automated pipe routing feature helps you with the designing ideas. Okay, the one that I show you just now during the PID demo, it's actually automated nozzle creation when it connects to the when a pipe connects to the equipment. Okay, but in Plant 3D it is similar like that. Okay, but it is for routing. Okay, like say the pipe, you're going to connect a pipe from a pump to a tank. Okay, so you don't know which way is possible or which way is best. So you just click one click, and then you can see the suggestions from AutoCAD Plant 3D. Okay, and then a spool and isometric drawing also can be created with all the form list and all the information needed. Okay, So this is an example of 3D piping videos. Okay, so I think I will show you a little bit demo on Autodesk Plan 3D and Inventor. Okay, so all right, first one is the go back to Inventor first. Okay, so this is the skid drawing that I have created earlier. Okay, so this file can be exported to AutoCAD Plan 3D. So in the environment, we have a BIM Connect. See BIM Connect, we can export building components. Okay, what I've already done here, I can export it into a .adsk file, which is the .autodesk file. Sorry, the Autodesk Exchange file. Okay, then when I export it, I save it to ADSK file, and then I can open it, import it in Plan 3D. Okay, so this is in Inventor, from Inventor. Then I go to Plan 3D. Okay, for example, this one. Okay, this one. So with few clicks, I can already import the file into the skid design into my Plan 3D drawing. Okay, let me change the environment first. Okay, 3D piping. Right, so you see there's multiple options that you can choose for the tool palettes and for the environment. There's a 3D piping, PID PIP, or you are using the ISO standard, XA standard, or DIN. You can choose in between these standards. Okay, so in 3D piping, so what I'm going to do is I'm going to import the equipment from Inventor. So convert Inventor equipment. All right, so I just choose the import this one, and then I choose the part that I already created earlier. Then I open it and place it into the drawing. Okay, so I think I choose the wrong one because that one is pretty big. In Inventor, before you export it into .adsk file, you can actually simplify the drawing. That means the smaller details of the drawings, like the screws, the nuts, are not included into the drawing because you don't need that in Plan 3D. Okay, all the screws, all the small items, all those small parts are only needed in Inventor and also needed by the manufacturer. Okay, but we don't need it in Plan 3D. So in Plan 3D, we can simplify the drawing and put it into Plan 3D for us to do the drawing better or simpler. Okay, so the Plan 3D on the equipment, sorry, you can see this is actually the XREFs. Okay, the XREFs, the external reference that different discipline is actually done by different people, of course. So what we do here, we get the drawing, the equipment drawing, we get the structure drawing, and then we combine it into one drawing. Okay, in the piping drawing, because the final drawing normally is either the piping drawing or the plan drawing. So the piping drawing will need the equipments and also the structure, because of course how do you do the piping drawing without the equipment? How do you connect it, right? So here's the 3D piping creation. Okay, for example, this is the spec. Okay, the spec available in here, the CS300. As you can see here, there's a spec editor that you can create your own spec. Okay, so for example, for this is CS300, and I'm going to route a pipe from a vessel to a tank. Okay, so oops, got the wrong spec. Sorry. Here. Okay, so sorry, come back to the skid design I just imported. So the skid design, when you import, it also reads the connection on the drawing. The connection, this connection was created in Inventor, but when you go you move in import it into Plan 3D, the connection is already there. So what you need to do is just to select the suitable nozzle for that. Okay, suitable nozzle, and then you can already create the pipe. Oops. Guess I need to re-import it. There's some error that I did earlier. Sorry for that. Oops. Okay. I will reopen the drawing first. Okay. Okay. So, example, I need to reconfigure it. The zoom, or you can toggle it here. Then you can see the properties. So when you select, you can change the properties of the nozzle. Okay, what is the pressure class? Okay, what is the end type? Okay, the units. And then let's say I'm changing it to 150. Okay, then you can select which nozzle that you want to use. Okay, and you can start. Okay, so you see, when I change the nozzle, the nozzle is already automatically created in the connection. Okay, so what I need to do is just route the pipe. For example, here, move it here, and then move it to the other side. 4,000 to the other side. Okay, I wanted to connect to this pipe. Okay, so when I stop here, then I just connect it to the pipe. Oops, this will try to connect. See, there's an automatic routing. Okay, you can either choose, oh sorry, choose the connection, the different connection. Okay, sorry, I do it again. Okay, here, and connects here. When I connect it here, okay, there's a multiple options available. It's either this one is directly change here, okay, or this one. So which one is better for you? Then you can click accept to take the suggestion. Okay, other than that, okay, other than that, you can also add the pipe supports. Okay, the pipe supports too. So of course the pipe needs the pipe supports in order to hold it. Okay, so the pipe support is also available. All the standards are available. This one I say that there's a lot of items, a library in Plant 3D, so you don't need to draw it yourself. You just have to choose which one is suitable for you. Okay, you can choose from clamp sanction. Okay, then displace it. You can see this one is very intelligent that it reads the pipe diameter, so it will put the size, sorry, the support accordingly. Okay, what you need to do is just placing it where you want it to be. Okay, right. So I have already put all the supports here. Okay, and also there's multiple type of the pipe supports as well, which is you can choose from here, the dummy legs, from the shoes, anchors or guides, okay, the base support or hangers. Okay, there's a lot of standards. Or if you have your own supports, of course, you can import the block from AutoCAD. Okay, right. Okay, so that's about the piping in Plant 3D. So in Plant 3D, see, there's a nozzle. I'll show you a little bit. Okay, I think I have another 10 minutes, so I have to move faster. So in orthographic drawing, so once everything is completed, then you need to produce the orthographic and isometric drawing. Okay, so for orthographic drawing, you have to what you need to do is just go to sorry, orthographic drawing, then demo. Okay, I open one. Sorry. Okay, there's already template there, but if you have your own template, of course you can always change it in your project setup. So I wanted to create a new view on the orthographic drawing. Okay. Hold on a second. Oh, sorry, it was in different screen. So I wanted to do the piping orthographic drawing. Select the drawing, okay, and then choose the the scale. I'm going to make it a smaller bit. Then I choose 1 to 100, and then go to paper check thing, and then click OK. So these box are actually what will be included in your orthographic drawing. Okay, this is front view. So I'm going to change to top view. Okay, the red one indicates which view that you are getting. Okay, so this is the top view that I'm getting. Okay, then everything included. You can see, we can check from the orientation. Everything's included in the box. Okay, so I just click OK. Then the 2D orthographic drawing will be created. Okay, so this is the top view. Okay, even you will even have the coordinates of the drawing, right? So from here you can get the adjacent view. Say from here I want to get the front view. I click front. Okay, then I just put it into the drawing. Sorry, adjacent view here, front. Okay. Oops. All right. So next is the another adjacent view on the isometric view. So it's like the adjacent view. Select the drawing. I go to southwest isometric. Now I got the isometric view of the drawing. Okay, this is about the orthographic. Okay. So the next one, the most important thing is the isometric drawing. Okay. So this is for the orthographic drawing, and I'm going to do the isometric drawing. Okay. Sorry, my screen is so small. Okay. So to create an ISO drawing, all I have to do is just select on ISO. Okay. All the pipeline that are available in your drawing will be listed here. Okay, so you just choose which pipeline that you wanted to do the isometric drawing. Select the settings. There's few settings that you can set beforehand, and then click create. Then the isometric drawing is created in the background. Okay, so you don't have to do the isometric drawing yourself anymore. So because this isometric drawing created based on your 3D piping drawing. Okay, so once it finished, the isometric drawing created, it will show you in the, oops, it will show down here that the isometric drawing has been finished or created. Then you can open the drawing. See, isometric creation completed, then you can open it. Okay. Okay, there's 3 drawings. Why 3 drawings? Because it actually has 3 separate drawing, because the line is pretty big, so it separates into 3 drawing. Okay, you can see all the information that you need in isometric drawing, all the connection, all the size, the items. Okay, continue from which drawing is listed in the isometric drawing. Okay, it even has the bill of material for each pipeline or each drawing, so you know you can get it directly from the 3D drawing. You don't have to create this yourself anymore. All right, so this is about isometric drawing, and I forgot to show about the 3D drawing earlier. Okay, so when you create a 3D drawing, earlier when I said that based on PID, there's an option that you can create the pipe drawing based on your PID line list. So what you have to do is just click on the PID line list. Okay, there will be the list of pipeline that you all previously created in PID. So when you open the PID line list, you can select it from here. So what it can do, you can create it directly here from here. For example, there's line number 1009. Okay, what are the spec, what are the size? But you just click place item, then you can already place the item. Okay, this is just example I'm going to do. Okay, and then what's inside the pipeline? one check valve and one gate valve. So just right click and place the item here. Okay, so it will place accordingly. All right, same goes here, the gate valve, just select it and then select the orientation. Then I got a pipeline. So when I select this one, and if I check on the properties, there's already the pipe layer, line name, line tag is 1009. So I don't have to create from scratch and redo the tag. Okay. Okay. So the last one will be the visualization. I got another 4-5 minutes. Okay, last one. So the final drawing that you have already designed that includes everything from the structure, from the equipments and piping. It can be easily exported into Navisworks. Okay, where the Navisworks is where you do the Navisworks is where you do the design collaboration. Also the clash test. You can even check the measurement of each item. Okay, you can see this is for the reviewer to see whether this design is designed accordingly or not. Okay, so you can add notes into the drawing. Okay, you can for the designer to have a look at when it needed to be changed. Okay, and then you can run the clash test. So the clash test is either from one parts to another parts or the whole project. So you can see all the clashes that occurs on the design. Okay, so the design also can be highlighted by just clicking it, and then you can see there's a clash between the valve and the structure, so that you can modify it accordingly. Right. So other than that, you can set a view. Okay, the viewpoint, you can save the viewpoint. You can create an animation of the view in order for you to do the presentation for the final project drawings or project design. Okay. Other than that, you can run the analysis. You can visualization, and then you have the ability to walk through in your design. Okay, sometimes we design, but we cannot visualize either that space is enough or not for a human to walk through. So you can put a third person here, and then you can walk through into the drawing, right? Into the drawing, to the design, and then you can import or the schedule from Microsoft Project or Primavera into Navisworks and do the scheduling here. You can set the actual date or the planned date. Okay, and then you can see the progress on a specific date, right? So from the simulation or of the schedule, you can create a animation on the progress. All right. So I think that's about it about Autodesk Navisworks. So Autodesk Navisworks is powerful to cater the large format, to review, to collaborate all the drawings. So from Navisworks, you can also use a virtual reality program or application to walk through your design. Okay, you have asset management, can export it to point cloud data. Okay, so all this large 3D model aggregation can be exported into Navisworks. Okay. All right, so this is the Autodesk product design manufacturing collection to sum up everything. So in one collection that we have AutoCAD, we have AutoCAD tool sets. Specifically, here is the Plant 3D and AutoCAD PID. We have Inventor Professional, the sheet metals. Okay, and then we have Navisworks Manage and also Inventor. Sorry, in cloud we have Fusion 360 as well. Okay, so these complete solutions that available in PDMC or Product Design Manufacturing Collection is to cater most of the industry, especially for plant design. So you have everything in here that you need, just the plant and PNID, and then you need a Inventor Professional and also Navisworks Manage. Okay, so I think that's about it. So what are the engineering benefits? So okay, the fast track projects. Does it feel like your project's behind schedule? You need to do multiple project tasks in parallel. So how will you meet the project requirements? Okay, so the specialized skills and resourcing, how can you maximize your efficiency with current staffing levels? Okay, are your best resources retiring? Okay, is training taking half year? And see, this one is very easy. So you have to ask yourself, what are the benefits? Are your investment in training risky because other engineering firms will hire them once they are trained? Okay, design errors. Okay, shorter design errors reduce the inefficiency, and also manage globally dispersed projects and teams. Okay, before we finish, there's a short video on
plant design
environment. Okay. Hold on, I'm going to share the sound together.
Engineers and designers need to work closely together to plan, design, optimize, construct, and manage today's complex process plant. The Autodesk collection has all the tools you need to design, engineer, and construct plant projects efficiently. Starting with process design, AutoCAD Plant 3D software allows you to create intelligent piping and instrumentation diagrams quickly and easily. Reports are created automatically, and information stored in the PID is connected to the 3D model for quick validation between the process design and the 3D plant design. With AutoCAD Plant 3D, you can continue with the design and layout of the process plant. Piping designers, structural designers, and mechanical engineers work together to design the plant in 3D. Piping designers perform spec-driven design of pipe layout. Structural designers access built-in libraries of steel sections to perform accurate structural design. The modeling tools in Plant 3D allow teams of piping designers to quickly lay out equipment, route pipes, and ensure connectivity. Bills of materials can be produced directly from the model at any time using Plant Report Creator. For designers performing retrofit design on existing plant facilities, Recap 360 allows engineers to bring point clouds into the Plant 3D model, allowing fast and accurate remodeling of plant facilities. For the design and layout of ductwork and cable trays, AutoCAD MEP integrates directly with the Plant 3D model. As the design progresses, design teams need to review the fully integrated model and check for physical interferences, as well as soft clashes, such as clear access to valve operators and safety equipment. Navisworks Manage allows the project team to collaborate closely and identify these clashes to determine resolution. At any time, reports and drawings, such as general arrangement drawings and piping orthographic drawings, can be created directly from the model. These drawings are easily updated during the design of the plant. And because the piping is all driven by piping specifications, accurate annotations and bills of materials can be produced at any time. Piping isometrics are created directly from the plant model. AutoCAD Plant 3D includes the isometric drawing software for the creation of piping fabrication isometrics and for piping erection isometrics for plant construction. Planning for construction can be performed in Navisworks. Using the model generated in Plant 3D, planners can start to plan the construction sequencing and develop a construction plan. By using the visualization tools, planners can check the validity of the scheduling and track the construction progress. Costs can also be assigned to the tasks to track costs throughout the project.
Okay, so I think that's about it. So I'm sorry that I was busy presenting. But
you think we can move on to the Q&A? Then we address the current ones in the chat first quite a bit. Then
yes,
I was
reading. Yeah, I was reading the chat just now. So I just realized that there's a lot of
I
questions.
mean, you
here.
want to start from the top. I think Gabriel
Yep.
asked, I think when you were doing the tagging, right, is the change in data automatically reflected in all drawings documents? I.e., is it based on a single source of truth database? He was asking.
Yeah.
I think.
Hold on. I'm scrolling.
Or I'll let you organize how you want to. Yeah, thanks.
Yeah. So this is based on single source of truth database. So in Plant 3D and PNID, this is actually everything is compiled in one folder. So it's not single source of truth like in cloud, but all the projects that created, for example, I'm showing you the PNID here. Let's say I'm going to create a new project. All the projects that inside here is, the directory, all the drawings or the drawings will be stored in this folder, which one you select. Okay, so this can be say a single source of truth, but in your machine only, not in the cloud. Okay. But of course, Plant 3D also can work with the Autodesk BIM Collaborate Pro, where you use the single source of truth in BIM Collaborate Pro with Autodesk Docs. Okay, I hope this answers your question. So, but everything is stored in the same folder. Okay, and also you can save it in the cloud as well. All right. So next question is, the symbol in Plant 3D are very generic and we would like to add more data like IO list. Okay, so the symbol in Plant 3D and PNID is fully customizable. You can create a symbol here and assign it as which is the equipment or parts that you assign it. Okay, you want. Let's say there's no hold on. There's no your type of buff in PNID. You can always edit and assign it as your pump. Okay, you can add table here, or you can do separate tool palettes tab for your own parts. Okay, right. Next is, can you share how you modify the sizes of tanks so quickly? That's actually, there's a feature in Inventor which is called iTrigger. So iTrigger, we have a iLogic as well in Inventor that allows the changes, the changes of the equipment or the design very quickly. But of course, you need some configuration on it. If you want to see on the demo about it, maybe we can do a separate session, okay, because it takes quite some time as well. Okay. The industry is working much closer with stakeholders for data standards. Is AutoCAD implementing open data standard which allows sharing of data? This one I have to check and get back to you, Mr. Gabriel. So maybe Marcus will keep in touch with you about this question. Okay. Other than that,
yeah, so actually took down that note ready for that.
All right, sure, thank you. So AutoCAD Plant 3D can export to step. Okay. So
no, I think one of the gentlemen actually replied saying that based on the paper question, he's saying that maybe step format would be one of them.
Okay.
IFC maybe we need to check whether can Plant 3D export as IFC format. That's the
IFC format. Okay, so to IFC format, I have to check it because I'm not familiar with it.
Correct. Right? I need to check. Yeah.
Okay, so Marcus will get back to you. All right, so guys, I think that's about it. Can you show tagging?
I think there's one more questions on the slopes. Creating piping.
The slope. Okay, the slope. So
yeah.
Okay, the slope. How to create a slope? So the slope, for example, this pipe. Okay, so if you see on the properties, you can immediately change the slope by changing the properties only. Okay. So you can see there's a port properties, pipe properties. There's a way to do it because centerability, top of pipe. Okay, So the slope can be changed from the properties only, just by changing the height of the properties. So let's say because I forgot where is it. There's a piping. There's a few yeah. There's a few options here that you can change to change the slope, but it's doable. Okay, but I'm sorry that I forgot how to do it, but I remember that I did it before. So to change it, just like changing the size, or not the size, the height of the pipe, and the start height and the end pipe. Okay.
No problem. Something I think we're a little bit overrun, so we will back this one. So yeah.
Okay. So okay. Thank you guys. Thank you for thank you for attending.
Charles, you want to take over? Yeah.
I think basically that's it. Like any more on the Q&A, I think we sort of overrun. So actually, you participants, if you have any questions, actually you could just approach us, post it on email. Yeah, you can follow up if you want a separate presentation, or you want maybe even further training inquiries from our side also. So I think basically, this is it. So yeah, I think thanks everyone for attending. Really quite overwhelming participation this time around. So we will be continue doing a series of webinars from the next few months. So do keep lookout on your social media and your email inbox. Okay, so I think that's pretty much. Thanks for your time, Mr. Samsu, and Charles also for hosting this again. So yep. I think we're good.
Okay, so anything else for everyone, or any questions? We just hold on for a couple of minutes, just in case anybody wants to ask any questions.
Yeah, in the chat window, just be online for a few more minutes. Yeah, if you want to leave any comments, we'll get back to you. Yeah.
Yeah, some outstanding questions we are not able to answer, we will get back to you separately through email.
So Marcus and Ichao, I'm closing down the session.
Okay, no problem. I think you are clear